The name is Bond. Chemical Bond. Part 1. Ionic bonds. Let's explore. Okay, so what happens finally when two atoms decide that they're going to get together and form a bond? How does this happen? Well, this is one way it happens. First of all, let's go and take two elements. All right. The first element is chlorine. Let's draw it. Cl is the chemical symbol, and chlorine is element number 17. All right, so remember now that everything about chemistry, all of chemistry happens with the electrons. Why? Because the electrostatic force is the one that we can mess around with, and the strong nuclear force that keeps the particles in the nucleus together, we cannot mess around with, not in chemistry anyway. That gets into nuclear bombs and stuff, which is really cool, but it's not chemistry. So basically what happens is, if you are an atom, and let's go ahead and continue to draw the electrons with the blue clouds here. If I'm chlorine, if I am number 17, and let's say I'm a neutral chlorine atom, that means I have 17 protons and 17 electrons. So, on 1, 2, on level 2, 3, 4, 5, 6, 7, 8, 9, 10, and then level 3, remember level 3 can also hold 8, 10, 11, 12, 13, 14, 15, 16, and 17. Okay, so it looks like I've filled up level 1, I've filled up level 2, and I've almost filled up level 3. If I only had one darn electron, okay, like this is that open space right there. If I only had one electron to fill in that open space, I would have a nice, complete, full third energy level. Okay, so that's chlorine. Let's go sodium. All right, this is sodium. Sodium is number 11. Sodium has 11 electrons, okay, to match its 11 protons. Energy level 1, 1, 2. Energy level 2 is electron 3, 4, 5, 6, 7, 8, 9, 10, and I've got one extra electron in energy level 3 just sitting out there. So sodium says, gosh, I have these perfect two filled energy levels at level 1 and 2, but then I got this random electron just sitting out here, okay, on energy level 3 with no partners. God, it's kind of weird, okay. In order to fill my third energy level, I need 7 other electrons. So here's sodium and chlorine. They're both kind of saying, gosh, they each have needs to make their outfits complete. So here's what happens. A bit of a negotiation occurs. All right, so let's now do it together. All right, and so here we go. Here's chlorine, and here's sodium. All right. So once again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and on this third energy level, we'll go 11. And then chlorine, actually, you know what? I'm going to erase chlorine. I'm going to move chlorine over a little bit. Let's move chlorine over here. Okay, and now let's look at chlorine's electrons. Ooh, we'll have to draw it small. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then here's our third energy level. 11, 12, 13, 14, 15, 16, and 17. Okay, so here's sodium and here's chlorine. And they look at each other, and chlorine says to sodium, hey, sodium, check out that cool extra electron you have. You know, if I had that electron, my third energy level would be so complete I would look awesome. And sodium says, whoa, chlorine, check it out. I have this extra electron. If I were able to get rid of it, then I would have my first two energy levels that would look totally awesome. I think we can, and you guys guessed it, work a deal. So here's what happens. In this particular case, it is in sodium's best interest to give the electron to chlorine and chlorine to take it. And that way they each end up with filled energy levels. So, here we go. Sodium has this extra electron sitting here, and it just goes over to chlorine, and it adds on to chlorine's third energy level, filling it up. All right. But, as we know, since chlorine was neutral and sodium was neutral, now we've had an exchange of electrons. So there's going to be some ionification going on here, right? So let's see what happens in the next slide. All right, so back to, here's chlorine, and here's sodium. So now we've got chlorine's first energy levels filled, chlorine's second energy level is already filled, we knew that, and now chlorine's third energy level is filled, and I'm going to draw the electron that sodium gave to chlorine. Okay, 1, 2, and then 1, 2, 3, 4, 5, 7, 8. I'm going to draw the electron that sodium gave to chlorine in green. Let's do it that way. Here's that electron that sodium gave to chlorine. Now, since chlorine was neutral and it got an extra electron, what does that do to chlorine? And if you said it makes chlorine a negative ion with a -1 charge, you're right. And since sodium was neutral and it gave up an electron, if you said that that made sodium a positive ion with a +1 charge, you would also be correct. Okay, because that electron left sodium, sodium now has, and we'll write it on top here. Okay, sodium has 11 protons, okay, but now sodium only has 10 electrons. Okay, so 11 protons plus 10 electrons is going to be 1 extra positive charge. Chlorine now has 17 protons, and it got an extra electron, so it's 18 electrons now. Okay, so that means it's got that -1 charge. So since chlorine has a -1 charge, and sodium has a +1 charge, they kind of love to hang out together now that they've done this deal here, right? So they just kind of stick around and hang around each other because the negative is attracted to the positive and they go on their little merry dance, okay? And that is what we call an ionic bond. An ionic bond, okay, this is an ionic bond, and that's when electrons are transferred between atoms. And what happens is you end up with ions with opposite charges that like to hang out together. And that is what an ionic bond is. Some common ionically bonded compounds, NaCl. Okay, that's table salt. Okay, let's see, what else? Lithium fluoride. Oh gosh, we could get magnesium iodide. There's all kinds of things. Basically, salts. Anything from something on the way left-hand side of the periodic table and anything from the way right-hand side of the periodic table will form ionic bonds, and we call them salts.